Hello, welcome to a quick demonstration on how to generate multiple regression statistics using SPSS. The file I'm going to use here is going to be an Excel file, so I'll be able to import it into SPSS and then go ahead and generate the regression statistics. Right, so in order to do that, you can go to File, and under File you see Import Data. And under import data, you'll be able to see the type of, you can select the type of data that you want. In this particular case, an Excel file. So I click on it, and then you go to where the particular file is actually stored. In this particular case, the file I need is banking data, and then I go ahead and say OK. All right, so it kind of gives me the format of the data, how it's actually going to come into SPSS, and yet it's also going to show me the data range from the Excel file. What I'm actually going to notice that there's going to be some cleanup we'll need to do, because it's actually selecting some empty cells, right? Okay, so depending on how much activity had taken place in that particular file in Excel, it may actually have an incorrect range. But again, that's actually going to be one of the activities we're actually going to do, just to clean up the file before we eventually use it. So we can go ahead and say OK. Right, see, now the file is actually here, and as you can see, the rows number 1 up to 6 is the actual file that we actually need, but there's a lot of empty cells or empty rows that were actually included as well, and they are being taken as if they are valid fields. So the reason why I included this so that I can actually show you as well how to clean up this very quickly. So what you can do is you click on the row number so that you select the entire row, and hold the Shift key button on your keyboard, and then you can scroll all the way down until you come to the end of the data, and then click there. So while you're holding your Shift key button down, right, as long as you select the first one, you can select the very last one, so it's going to select everything in between. Once you've done that, you can go ahead and say Edit, and then Clear to delete. All right, so all that is actually gone. Now we're actually left with the specific field that we really needed, right? So it's very important to remember that whenever you import any data into SPSS, you have to clean it up to make sure that it's actually making sense. And here we are actually in variable view, where we're actually able to define the different fields for this particular data set. Now everything else looks about right, so we don't need to do anything else. Now if you go to data view, you're actually able to see the actual data itself, right? Okay, and we can actually scroll down. You're actually able to see that everything is actually being imported correctly. And while you're here, if you wanted to save this particular file as right, so you want to save this file as an SPSS file, so that at least we have something to go back to. Right, banking data. Let's call it practice. It's a practice file, and then we say save. Again, it recognizes that I already have the same file name, so we want to overwrite it. There we go. So now that we have this file imported, it's now time for us to generate the multiple regression statistics. All we have to do is we go to Analyze, and under Analyze we go to Regression, and under Regression we want to go to Linear. So we click on that. All right. So then now we have to specify what we want to do. We know that in this particular data set, it's a kind of banking data, so we want to predict the dependent variable, which is actually the bank balance, right? So in other words, we want to evaluate whether any of these variables, any of these independent variables, age, education, income, home value and wealth can be used as predictors of the bank balance at the bank, right? So our dependent variable therefore is the bank balance. Then we have age is one of the independent variables, education, independent variable, income, and home value, and wealth. Okay, so now while we're here, we can actually look up with the statistics. Everything else looks about right, but in situations where we've got multiple regression analysis, we've got multiple independent variables, it always makes sense to include collinearity diagnostics so that we can, as we generate these regression statistics, we are actually able to evaluate to see if there are some independent variables that are explaining the same thing, right? So you're likely to find when you've got multiple independent variables that there are some that can actually be redundant. And so including the diagnostics for collinearity will help us to evaluate whether we have got multi-collinearity in our model that we can later actually use to clean up the model so that we can come up with a much stronger model. But at least we'll be able to evaluate and have a good feel of the model fit, how good this particular model is actually going to be. But this is something very useful that you may want to include. Right, so I'll briefly explain what collinearity diagnostics actually mean once these have actually been generated. Okay, so then we say continue, and otherwise we don't need to do anything else here. We can just go ahead and say okay. Then the SPSS will generate the output file. Now, just a quick interpretation of what this output file actually means. From model summary, going downwards, it makes more sense for us to interpret that because that's where there's actually meaningful statistics, right? But otherwise, generally, you can see that there's a model summary, there's an ANOVA analysis of variance section, which is pretty standard, and there's also the coefficient section. Now, you'll notice that coefficient section is actually including collinearity statistics because we checked that up. Otherwise, if we're not checked up the collinearity diagnostics, then this was not going to show up, right? It's very, very useful. And basically what the VIF actually stands for, it stands for variance inflation factor. So basically when you're actually reading this, it's simply telling us that if the VIF is equal to 1, it means that there's no correlation between the independent variables. But if it's between 1 and 5, it means that the correlation is moderate. So in other words, there will be some independent variables in the model that are moderately correlated. But anything greater than 5 means that the correlation is very high. Okay, so basically that's how you interpret this. And by just looking at this here, you can actually begin to see that 1, 2, 3 independent variables do have low VIFs, which is variance inflation factors, whereas the other two, income and wealth, are quite different. They're quite high in that particular regard. So basically, again, that's actually a topic for another day, but I just wanted to kind of include these types of statistics so that we can actually use them to diagnose if there is any multi-collinearity in our model. In other words, they want to detect whether there are 2 or more independent variables that are explaining the same thing, which means they will actually be redundant. And it always makes sense when you're cleaning up your model to remove them, right? So that you can come up with a model that is much more accurate and much more reliable. But otherwise, besides that, as a general rule, it's always important to explain the model summary, the multiple R, right, which simply means it's measuring the strength of the relationships. that's collectively, right, between the 5 independent variables and the bank balance. So it's telling us that the strength is at 97%. That's pretty high. Okay, then the R square is explaining the coefficient of determination. In other words, how much of the variation in the bank balance is being explained by the 5 independent variables. So it's actually at about 95%. But as a general rule, we tend to use the adjusted R square because it's adjusted for the sample size. Right, so our sample size could actually as well be a limitation, therefore impacts on our estimations. Right, so 94% is widely used because it's a more conservative number. Otherwise, the standard error is simply just showing us the standard deviation adjusted for the sample size as well. Right, so the big picture perspective on the model summary, basically, again, the strength and the coefficient of determination, how much of the variation is being explained. Of course, as I've already said, that we tend to use the more conservative R square. An analysis of variance, simply just giving us the summary that collectively are the 5 independent variables statistically significant in their relationship with the bank balance, and yet it's telling us that yes, they are, because collectively they are actually lower than 0.05, right? So this is our collective p-value right there. And then we move on to the coefficient section, where we are now able to actually look at each individual independent variable with its relationship with the bank balance, whether it's statistically significant. We can see that age is statistically significant. Education is not, because it's higher than 0.05. Income is statistically significant because it's actually lower than 0.05. Home value is not, because it's higher than 0.05. And wealth is statistically significant. So again, here, by just looking at this, we can comfortably say, based on this particular data set, age, income, and wealth are statistically significant for this particular model. Then, of course, that is likely to force us to then look at the variance inflation factor and see if there is a variance, rather a variable that we can actually exclude from this particular model to improve its functionality. Otherwise, beyond that, it's always useful to interpret the coefficients down here as well, right? And what do these actually mean? Right, for example, for the age, the coefficient of 3.318 means that for every change in the age, the bank balance will increase by $319. Okay, so for every change, every additional change in the age, as the person gets older, the bank balance tends to increase. With education, every additional year that's actually added in terms of education increases the bank balance by $622. And income, for every additional dollar of income, the bank balance tends to increase by about 15 cents, right? And with the home value, for every additional additional change in the home value, the bank balance tends to increase by about a penny, right, when we round that off. And of course, every additional dollar in wealth will actually increase by about 7 cents. So it's a very, very useful way of actually interpreting the coefficients, because really they bring about the application implication of this particular model. It tells us a lot more things that we could actually in practice help predict, those bank balances, with our customers. But again, our interpretation is limited to this particular data set. So its generalizability is limited by the limitation of course, the sample size, the data set, depending where we actually got this particular information from. And also bearing in mind that we've actually been able to explain only 95% or 94% of the variation of the bank balance. So there is another 5 percentage points that is not explained, which could be one additional variable, several additional variables that could actually make that particular difference. And or it can as well be revising the model, eliminating some of the independent variables that were not statistically significant, could as well improve how much of the variation is actually being explained. Otherwise, that's all I have for you. I thought this would be very useful multiple regression activity, especially beginning by importing data that was not as clean coming from Excel, that we actually had to go through the process of cleaning it out, and then of course going ahead and generating the multiple regression statistics. All right, thank you so much for watching. Again, like the video, share the video, and be sure to subscribe. Thank you so much for watching, and bye for now.